Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this little 2014 Chrysler Town Country. This little Chrysler has a 3.6 V6 engine in it, and the engine is misfiring with heavy trim takeaways. This car is here from another shop. They've already put coils and plugs and all the other parts that never fix anything. So what we need to do is diagnose this car correctly so we can get it fixed. So the first thing I want to do is get a scan tool and just get some basic data on this vehicle. Let's go ahead and get that scan tool connected. Okay, I got the scan tool data up right here. I'm really rich, but I have no vacuum on the motor. The motor has very, very poor vacuum, like it's a mechanical failure. And I've got no fuel control, and I've got a huge trim problem. So let's look at the DTCs. Okay, a P0300 Random multiple misfire and a P0305. So I've got multiple misfires and I've got a cylinder on 5 misfiring. So let's look at the data here. Look at the trims. We have -33 and -33, and it's on both banks. But this is a speed density system, guys. And we can see that we don't have good vacuum. And this car is barely running, guys. It is running horrible. But I can see I have a vacuum problem. Now, if you've got low vacuum, the engine thinks I'm under load, and if it thinks I'm under load, it's giving a lot of fuel, so it's got to take the fuel back away with trim. The trim problem is being caused because I don't have any vacuum. Now, let's look at mode 6. Yeah, this thing's running bad. Okay, so I can see one bank, 1, 3, and 5 all misfire, and I got no vacuum. That makes me think that something like the camshaft is out. So what I want to do is I want to run a relative compression test. Now, if I run a relative compression test and the cam is out, maybe I can see I have 3 low cylinders on here. This won't identify what cylinders are low, but it will give me an idea if I have 3 cylinders that are low. Okay, so we have one really low cylinder and one we got 2 low cylinders on this engine. Now I would think that if we had a cam out, we might have had 3. That's sort of what I was hoping for, is we might have 3 showing that cam is out, because we know a whole bank has got misfires. But we definitely got a hole that's got very low compression. And I can even see it up here. You can see how we have current draw, and you see how we missed one right here? Well, when we missed one right there, that's a really low hole, guys. So this has a problem with the cylinder pressure. This is a cylinder pressure problem. And you're never going to fix that with spark plugs and injectors and all the other things they've done on this vehicle. This looks like we have an actual mechanical failure on this engine. So now is what I want to do is I need to get a oscilloscope, and I want to verify what cylinders are misfiring, and then we need to run a cranking compression test so it will identify what cylinder is at fault here. Okay guys, I connected the scope, and I connect channel 1 yellow to the crank sensor and channel 2 red to the ignition. So this is my data right here. So this is what we're going to process. Ignition strikes, and this is the crank sensor. Now we're going to take this crank sensor and we're going to make an algorithm. So we want to go over here. I need to pick the firing order for this car. 1, 2, 3, 4, 5, 6. I've got cylinder 1 selected. Now we're going to, the car is missing. It's barely running. It's barely idling. Okay, so we have 1, 3, and 5 misfiring, and 5 is far worse, 26 to 3, 7 to 1 is 18. 1 and 5 are the main misfires, but 5 is really got a bad misfire. Now the way we're doing this is we're looking at the crank velocity. Do you see how right here the crank velocity sped way up on 4? Right after 3 it sped up, because 3 it drops, and then 4, and then look at 5 drops way down. And do you see how right here that's 5, it drops way down? 5 has got a hard miss. It's not firing at all. Now let me show you. 1, 3, and 5. So that's the right bank, back bank, and all 3 of those are missing, and something's wrong with this cylinder right here. 1 has a good miss, 3 has a miss, but I think the cam is out, as we already saw from the scan tool data. I'm pretty sure that this cam is out. So the first thing I want to do is I want to just verify the cams are in and out. So I want to get in 1 and I want to check the compression. I don't know that I have a cam crank for this engine. I have one for a newer engine. It's probably the same, but I don't know that, so I'm going to go with a pressure transducer. Because guys, there's no way we have every cam and crank for every car we work on, you know, but I can get a compression waveform from almost any car I work on. So let me go ahead and get into cylinder 1 and let's get a compression reading on 1 to see if we can figure out if that cam is out, because I think that this cam in this bank is out, and that's why I have no vacuum, and that's why they're all missing. And then we have something further wrong with 5, because it's not firing at all. He's sick, and we know we had 1 low cylinder, so we'll still need to run a test on that as well. Okay guys, in order to run a relative compression test, we need to hook channel 1 to the battery, negative to the negative post, and channel 2 to the number 1 coil. We're going to run a cranking compression test. So we want to go to compression, set the firing order up. We're on ignition 1 for our signal in. So we've got 2 low cylinders, we've got 1 low on 1 and 1 real low on 5. So we have a cylinder 5 has low pressure and 1 has low pressure. So we need to get in cylinder 5 and see what's going on with that cylinder, why it's so low. And we can see right up here, we have a real low. Do you see how it went and it goes way high, and it's not a pull down? We've got current, 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 and then there wasn't even current. It just goes to the next cylinder. This hole is really, really bad. That's what the waveform tells me, and the scope is showing me that. So that's correct. So 5 is my dead hole, and 1 is also low on compression. Now that we've seen the results from the cranking compression test and we know 1 and 5 have low cylinders, I don't want to use either one of those cylinders to check the cam timing. I've got the pressure transducer in cylinder 3, and this is channel 3, it'll be green. I've got channel 2 red connected to the coil for that same cylinder 3. I've got the intake pulls, I've got them coming off the intake manifold right here with the vacuum transducer. We're going to take the tailpipe pressure sensor and I'm going to use the blue hose. I don't want a Venturi. I'm not looking for misfires. I want the pressure pulses. So this will get me the pressure pulses from the exhaust. So we're in cylinder 3 right now, and I've got that in. The compression in cylinder is on green, and the tailpipe is channel 1 yellow, and the blue is the intake pull blue. So now the way I'm going to set that up is I'm going to just push this PSI button right here, and it automatically will load the data for us. So now we're ready to get the data. So now we just need to crank it up and let it run and look at that data to see where this camshaft timing is. It's actually idling, which is pretty amazing. So let's just stop the data and let's take a look at it. Okay, so let's go ahead and look at this data. I'm going to get the zoom window. I want to come in and we want to look at this. This is great because this car is actually idling right now, and it usually won't even come close to idling. So we're going to take our cursors and we're going to put a cursor through the peak and through the peak, and then I'm going to mark the cam. Now we want to look at this data down here. So I'm going to take my zoom window and I want to come in down here where I can see better. I want to go right now, I want to shut off the intake and the exhaust in the ignition. Okay, now the exhaust right here should be happening usually about 60, so that seems a little off, but that's close, it's within a target. But this intake is off. Do you see how my rise, this starts to rise right here at 30 degrees? So 30 degrees after bottom dead center right here. I'm rising. Well, that rise normally is way over here. It's past 60 on these engines that I've tested. Most of these engines are at about 70. So what that means is the rise is happening right here. I can start to see that rise right here. And if I get this cursor here and I put it on the bottom dead center mark, I can see I'm about 27 degrees on the rise when I close that intake valve. Now, normally that position is at about 78 degrees. It's over here on these engines. This has late timing. So this is off quite a bit. To give you a better idea, let's move this guy along just a little bit. That's 70 degrees. So that's more where I would expect this rise, between 70 and 75 degrees. Now, let's measure where that would be from. So normally, this is where we're rising from right here to here. So I'm 44 degrees off target there. And the intake is off on this as well. So if I come over here and I measure where my drop is right here, the drop down, that drop is usually 10 degrees after top dead center. Well, this is now 40 degrees before. So again, both sides are about 40 degrees off. And anything on the screen that moves to the left is advanced. So this cam is advanced. Now is what I'm worried about is I need to check the phaser and the control of the phaser, but the cam is definitely off. That intake is 40 degrees off on both sides, on this side and this side. So normally this drop is going to happen. That drop on these cars I normally expect to see 10 degrees after top dead center. So roughly that drop right here should be dropping right here. Now that drop is happening way too soon because it's over here. It's not after, it's way before. So that clearly, with both sides of the intake showing off, the intake cam would clearly show to be advanced, and it's about 40 degrees advanced. So that's a couple of teeth, or the phaser is on. So we need to check the phaser. Again, the exhaust seems to be pretty close to being on target, but the intake appears to be off to me. This is not what I expect from these 3.6 engines. I expect these are usually late. The intake valve opens late, and the intake valve usually closes late. Like it closes at about 75, 78 degrees, 70 to 78 degrees closing, and about 10 to 15 degrees after top dead center. So both of these are happening before they move to the right, so the cam is advanced. Now we always want to check these in multiple positions. So that's one position. Let's come over here and just look at it. Never just check the compression waveform in one location. We always want to look at multiple locations here. So let's mark this guy. And again, I can see that the drop is way before. That's 30 degrees, so that's before the 30, so that's way too early. That's like 40 degrees too early. And if you follow this down, do you see how I rise? That's 30 degrees, and I close that valve and I started to go up. So again, this cam is advanced and the exhaust looks about right. So I'm having a problem with the intake cam on this engine in some way, because this just isn't right. The next thing we want to do is let's go back out. And my overall pressure on this cylinder isn't too bad. 140, 130, 138, 140 on the pressure, which is pretty good. I want to go ahead and I want to turn the intake and the exhaust back on now. And now I want to come up here and I want to change this. We want to mark the intake. So right here I can see that this is the intake for 1, and I'm dropping vacuum on 1. I'm dropping vacuum a little bit on 3 as well, and 5 is just flat. It has no draw up, but it's not just dropping down either. But I can see 1 and 3 are dropping down, and we can do this. We can zoom in closer so we can see this better. See on 1 this is a drop. I have vacuum up, 6 pulled up, 1 just drops. 2 pulls up, 3 drops down, 4 starts to drop, and 5 just sort of stable, and 6 goes up. But I really don't see 5 dropping, and 5 is my worst cylinder. We still need to get in that cylinder, but something there is different. Okay, so now is what I need to do is I need to get a cranking waveform. And when we're cranking that, I can hear that low cylinder in there. Okay, so let's see what we've got here with the cranking waveform. So we can see these spikes up. That's from the ignition strikes. So if we want to clean those, I'm going to smooth the data. We'll smooth the intake, or the, now we'll come in and look at these. So we'll zoom in. We can see that the exhaust is between 30 and 60. That's probably about 50. We can actually measure that. So if we get this cursor here, and we put it on the bottom dead center mark, and we put that at the lowest point. That exhaust pocket, that's basically 46 degrees before bottom dead center, and that's what I would expect. Now this looks much better now over here. Do you see how I'm going all the way to 60 and then I'm rising on the intake? Like this looks better. I come across, that's 30, 60. We can measure that again. Now rather than being down here at 28 or 30, now I'm rising at 61. And usually, again, these rise at about 70 degrees, 75 degrees. So it's still off, but it's way closer. So that cranking looks better. And this intake pull, notice how it's after the bottom dead center. So what this makes me almost think is when I'm cranking it, the cam is in time. I even wonder if the VVC solenoid is leaking oil and it's advancing the cam from an oil loss. And we still need to get into that VVC and make sure it's not trying to control it. And we always want to do what? We always want to look at a couple of waveforms. Never just look at one when you get them. We always want to look at a couple when we're doing pressure stuff. So we're going to mark each peak, mark cam. Then we're going to get our cursor or our zoom. So again, that's bottom dead center, 30, 60. I'm about 50 degrees there. I'm dropping about top dead center is what I expect. And I close the valve at 60 after top dead center. And that's our bottom dead center. And that's what I'm expecting. So again, I'm dropping, the valve opens at about top dead center and I get my drop down. I go across and I go 30, 60 after bottom dead center, about 60 degrees, and I go up. So again, these look real good now. This is about what I would expect, but when it's running, it's way advanced, but when we're cranking, it's not. So now is what I'm interested to do is I wonder if running, it's moving, and I wonder if that VVC solenoid is leaking oil and it starts to advance that cam, because that's almost what this looks like, because cranking is correct, but running is not. Okay, so I got the intake cam VCT control right here. And I've got channel 5 white in one of the wires and channel 6 purple in the other wire. So now we can see if this is getting any control command or it's just leaking. Okay, so now we're going to start this up and get some data, and I want to make sure that that VCT is not being commanded on by the control system. Now we just got to hope the thing will idle. Sometimes this car runs better than others. Okay, so here we've got it. So I stopped it. I want to look at some data here. So it is idling, which is very helpful. Mark it. Okay, so right here we can see we're opening early and we're closing too early. So the intake is closing way too early and it's opening too early, so the cam is advanced. Now white and purple are at 0. I have no control on them. So I'm going to turn this off and we're going to look at these. That's white and that's purple, so there is no control. So that's my control. So that I'm not controlling it and the cam is advanced. That makes me think that the cam phaser is getting oil from the solenoid when it shouldn't. The solenoid should block it off and the oil is bleeding through and it's advancing that cam. So I think this is a VCT problem now. It definitely isn't controlling it. Okay guys, I'm taking out the spark plug on cylinder 5, and we can see that there's a brand new coil on the cylinder 2. This is the dead hole that doesn't fire at all. They've been trying to fix this. Oh yeah, that plug hasn't fired at all. It's new and it hadn't even fired. Okay guys, I'm in cylinder 5. This was the hole that doesn't fire at all. We need to get some data, so let's get some pressure transducer data now. Boy, it doesn't want to run at all. Let's see what we got. Okay, we have no real pressure at all. So we're only making 4750 pounds of pressure. In the waveform, we just have no pressure, and that's only when I was revving it. When we're idling, look at how small the pressure is. So we've only got 3 pounds of pressure basically. We have no pressure at all. So to mark anything really isn't going to work out very good for us, but we'll mark it anyway. But there's not enough vacuum in the cylinder to do this, and there's not enough pressure, so this really doesn't work to mark them. But we can clearly see that when we're just idling, we have just no pressure. So let's look. The intake pole right here. See where when one opens it just loses all the vacuum and it never really recovers it. We're not recovering on 3 or 5. We lose the vacuum and then we're not pulling back up. But we definitely have no pressure in this cylinder to speak of. I mean, this is really, really low. But I don't see where when I come up on pressure I'm blowing the waveform down. So let's turn on So I just don't see the problem with the pressure of the vacuum or the pressure, vacuum, or exhaust. I really don't see it right now. So if this pressure came up and the intake valve wasn't sealing at all, I should see a drop in that vacuum, and I really don't. And if the exhaust was leaking, either when the piston went up or down, I would have an exhaust state change, and I really don't see that either. So I really don't see either. So what I want to do now is I want to check the crankcase. I want to make sure that the pressure isn't going by the rings, because I don't see it in the intake or the exhaust. So in order to get the crankcase pressure, we're going to pull the dipstick out. We're going to take a spark plug boot and we're going to put it over it. And now we need to make sure this tube isn't under oil. So I'm going to blow through it, and it's free. So I know that I can use that port now, and it will work very well. So now we're going to take the tailpipe sensor, and we've got it connected to the crankcase. Now that will give me an indication if we've got ring blow-by, and that's where my problem is. So now we need to get the data. Okay, let's go ahead and start this thing up and see if we've got any blow-by. Now the best time to test for blow-by is just like what we did during cranking. So we're going to come in and we're going to look at this data here. Wow, the rings are bad on this. So the yellow trace, the crankcase is coming up. Do you see how I've got it's coming up right here? Every time I have a slight pressure in the cylinder, the crankcase is coming up. The crankcase is coming up. Oh wow, I didn't expect that. Wow, that's so cool, I can't believe it. Yeah, watch this. I'm going to smooth this data. Do you see how when the pressure came up, it went by the rings and it went into the crankcase? That's the crankcase, guys, the pressure. That's going by the rings there. So this engine has a ring problem. Now, we've got a cam control problem, but we also got a ring problem. The rings have a problem. They're leaking for sure. And with the mileage on this car, I mean, I don't know. This isn't a matter about diagnosing it and fixing a simple fix. The rings are bad. It basically needs the motor overhauled or a used motor or whatever they choose to do with this. But the rings are bad on this, guys. Wow, what a difference that is. That's grim for the customer. It's cool for us. I can't believe the rings are bad on this. I did not expect that. Yeah, the rings are bad on 5. Now, I don't care what you do with spark plugs and coils and injector like what they've been trying to do to fix this car. You're going to need an engine to fix this car. Okay, guys, that's pretty crazy right there. I did not expect to see that, but that's definitely a ring problem. You can see how rhythmic it is. Let's go ahead and let's shut off all this other stuff so it's easier to see. You can see its rhythm. It comes up every time. Well, the yellow is the tailpipe pressure transducer. And when it goes up, that's pressure. So that's pressure there, pressure there, pressure there. So that's pressure. So the pressure, and you can see the in-cylinder, every time the in-cylinder tries to come up, rather than compressing the air in the cylinder, it's going by the rings and it's going into the crankcase, and that's what's making this rhythm here. So the rings are bad on 5. That is not what I expected, but man, that's a cool problem to see with pressure transducers. And that's important to know this before we start doing any work on this car, because you could get in deep and not be able to fix this misfire. Wow, okay. There you have it. Okay guys, is this one cool little town and country? This 3.6 is just cool, guys. When I came over here and told me he thought he had a low cylinder and the pressure wasn't any good, I thought for sure it was going to be a rocker, because I've had a lot of problems with the rocker and lifters on these 3.6s. I've seen a lot of issues like that. So here I came expecting one thing, but you know, that's why you never expect what you think you know, because you don't know. Let the data drive the diagnostics. We got the data. I surely didn't expect the rings to be bad, and I surely didn't expect the VCT control to be bad, to be leaking. But here we have a double problem on this car. We have the VCT solenoid leaking oil and creating a phasing issue where the cam is advanced, and then we have a problem with the rings leaking. So man, if you don't have tooling and a little bit of knowledge, how are you going to diagnose this car? What, are we going to be like the rest of these guys that worked on this and put a spark plug and an injector in this car? And you're never going to fix it, guys. We're going to have some more education and some tools. Man, you got to have scopes and transducers. If you guys get scopes and you have the proper tooling, you too will be successful in your base.